All right, I'm going to share my screen, but just let me know if you can't see. Okay, we're good to go. All right, so I'm going to share my whiteboard. And yeah, okay, so let me know if you can't see this whiteboard. Just please unmute and comment so I can share again, but I'm just going to assume that you can see it. So you're seeing a table on the left, which has payment methods as the first column and then customers in the second column. So just a recap of what we did last week, because this week is a continuation of that. There are 3 tests that you would use the chi-square distribution for. One is to test for independence. Okay, so you test for independence. The second test is for equal proportions. And then the third one is the goodness of fit test. Now we've done these 2 last week, okay? And this is what we're going to cover today, the goodness of fit test. All right, so the goodness of fit test, what it basically does, it checks, well, it tests statistically whether a distribution has changed. Okay, now, by now you should be familiar with the distribution, but if you're not, I'll just do a quick recap here. Let me just draw a histogram, right? And instead of drawing the blocks, I'm just going to draw the curve. Okay, so the distribution is like this, right? Something like that. It doesn't have to be symmetric, but it's, say the mode is somewhere around here, which is like making up numbers, right? 34. Now this distribution could be anything. It could be the distribution of students' marks for this course 10 years ago, right? So say it was the distribution of how the students scored for this course 10 years ago. And what we want to do is we want to test statistically, has that distribution changed from then to now? So we want to check, has the distribution shifted? Does it look like this now, where the peak is now here? Could it be that? Or could it be this? Could it be this? Peak somewhere around here. This is another option. So the test basically checks whether they're different, okay? And that's what you're basically going to test your H0 H1. Your H0 is that it is the same, so it means it hasn't changed much. Statistically, it's pretty much the same. Or H1, it's not the same, it's different. That's what your H0 and H1 is. Okay, so I'm just kind of summing it up, but this is not how you would write it in your answer. Okay, the distribution is the same. We'll get there. The distribution is the same. And H1 is the distribution is different. And this is important, or should I say, it's used in the real world because if it's different, you need to approach it differently. Okay, you need to take action as a business, as an institution, etc., and change things. So if you look at this example here, some time ago, this is, if they took a sample of 200 people, they found that 41 of those 200 paid cash, 49 paid paid by debit card, and 110 paid by credit cards. All right, and maybe now that has changed significantly, and it's easy to understand that it would because there's a lot less people carrying cash. So practically in the real world now, we would expect the number of people paying by cash has changed a lot compared to, has decreased significantly from then to now. So for instance, maybe before, let me just draw this. I had to draw the 3 methods here on the bar chart. Say we had cash, this bar, which is the lowest. Then you had debit card, which is slightly higher, 49. And then you had credit card, which is like the highest, like 110. Right? So that's what it was then. So this is cash, this is debit card, this is credit card. And what we want to What we want to do now is we want to test whether that has changed from then to now. Maybe now the cash is like this low. Debit card probably increased a bit, and then credit card is even more. Okay. So we're going to test whether the distribution has changed. Okay. So basically, has the green bar significantly changed from the blue bar? Okay. So that's what we're going to tackle in this problem. Does that make sense? Before I continue, everyone good? Does everyone understand what we're trying to achieve by the goodness of the test at a high level? How we do it is what I'm going to cover now. I'm just going to assume all good. Then it's going to catch it. I'm going to hide this. Thank you, Shaginivo. Fantastic. All right, let's get back to the board. All right, now let's see how we do it. Okay, so please feel free to stop me and ask me any questions. But I will check into the chat to see if there are any questions. All right, so I'm just going to clear this out. All right, so we're doing the test. All right, let's start question A. There's only one question to answer. So I'll leave it as blue, right? So this is the payment method before, right? Some time ago, if you had 200 customers, if you total this, you'll get 200, right? 41 plus 49 is 1, plus 110 gives you 200. Okay, so this is what it was observed. Sorry, this is what it's observed now. Okay, this is observed now, all right? And if you read the question, it says, financial officer of electronics company sells TVs, sound systems, DVDs, VCRs. Okay, so this must have been a while ago because these DVDs and VCRs almost non-existent now. Okay, so we know from past experience that 23% of the store's customers pay by cash, right? 35% pay by debit card and 42% pay by credit card. Okay, so you want to confirm that this is still the payment method for electronic goods, right? So based on random sample of 200, this is what they got. So this is what they observe now. Okay, so this is your F0, this is your frequency, what they observe now. But in the past, that expected frequency, right, so I'm just going to put here FE percent. In the past, the expected frequency in terms of percent for cash was 23%. Okay, so it's 23%. For debit cards, it was 35%. Let me just get this out. And then last is credit card, it is 42%. All right. This is what the expected frequency was before. Okay. So the question says, use the chi-squared goodness of the test to determine whether the payment pattern of the past are still relevant today, and there's your level of significance of equals to 5%. So let's start with step one, state your null and alternative hypothesis. So as I mentioned earlier, okay, your H0 is that the distribution is the same. Okay, so H0, but don't just say distribution is the same, always answer it in terms of the problem. Okay, so you would say the distribution of payment methods, because that's what we were looking at, distribution of payment methods. I'm just going to write PMT for short for payment, but just know it's payment, okay? Payment methods is the same. Now, if you wrote H0 properly, like how high I have, okay? For H1, all you got to say is payment methods have differed or changed. As long as you write one of them properly, like how I wrote H0, for H1, you just need to say the opposite. Payment methods are different or not the same. It's up to you. It's just the opposite. Okay, that's how you would state your H0 and H1. Now, step 2 is find the rejection region. Step 2, find the rejection region. Okay, now before last week, okay, we had to find something called the degrees of freedom, df. df. And the formula I gave to you to use was r minus 1 into c minus 1. Now that's what you use for the test of independence and for the equal proportion test. You don't use it for the goodness of fit test. For the goodness of fit test, use a different formula, okay? And you need to use this formula here, which is K, and I'll explain what these symbols mean. K minus M, right? It's plus 1, let's check. Right, 1 second, write it down. I don't forget. K minus M plus 1. Plus minus 1. Okay, K minus M minus 1. Let me just write this down. K minus M minus 1. Okay, so people, you need to remember this formula. As you can see, clearly I didn't memorize it, but you will need to. Okay, it's not given in your formula sheet. So you, for the goodness of fit test, you use this formula. Okay, for all other chi-square tests, not this one, you use r minus 1 into c minus 1. Right, it's a rows, number of rows minus 1 times the number of columns minus 1. But for the goodness of fit test, we use the one above, and I'll explain what K and M are right now. So K is your number of classes. It's easy to remember this. I know it's up to K, not C, but just remember K is the number of classes. And what do we mean by classes? It's actually a number of categories. How many categories do you have? Well, you have cash, debit card, and credit card. So 3. So your K is 3. So it's the number of classes, right, which is equal to 3 in our case. Your M, okay, your M is the number of parameters. Now, what you need to take away from this is I'm going to copy something and paste it here because this is all, it's also in your textbook, but I'm just going to put it here so you can see it. Okay, now, in this table, right, what you need to remember, okay, if the question doesn't mention anything about a normal distribution, if it doesn't mention anything about a normal distribution, it doesn't mention anything about a binomial or Poisson, okay, then assume M is 0. Okay, so if you don't see anything mentioned about normal, binomial, or Poisson, then you assume M is 0. But if they say normal distribution, so test if it's a normal distribution, then you need to remember M is 2. If it's a binomial or a Poisson, then it's 1. M is 1. Okay, I need you to remember that. You're not given this table, okay? Dude, the best I can tell you is to memorize it, but I can explain to you what those numbers mean. Okay, so let's just look at a normal distribution, for instance. Now, for a normal distribution, which we've done in the previous learning units, remember we did the whole Z equals X minus mu over sigma. We had to standardize it and then use the table. So in other words, in order to find the probabilities, you would need to know this. You would have to know mu, and you would have to know sigma to infer probabilities. So there's 2 parameters, 1, 2. That's why your M is 2. Okay, it's the number of parameters that have to be estimated. For the binomial distribution, okay, I know it is a while back, but you would have to use the formula NCX, x to the p, and then 1, what is it, 1? No, sorry, my bad. It's this formula. You don't have to know the formula. All I'm trying to tell you is that there's 1 parameter. It is p to the x, 1 minus p to the n minus x. Right, x is given. So that's why here we don't include the x, because x is whatever the problem is asking you to work out, x will be given. The same here, x is always given. But there's the p that you need to know. There's only one parameter you need to know. It's 1. You need to know the p. So that's why you would see for the binomial is 1. Now you may ask, okay, what about the n? Well, n is also has to be given to you because it's the sample size. It isn't a parameter. Okay, the distribution may use it, but your sample size is provided to you. Okay, so that's why we don't include the n. For the Poisson distribution, there's only one parameter that you need to know, and that's the mean. Now, I don't remember the formula offhand, but for the Poisson distribution, it's something like this: x factorial, a to the x, and e to the minus a, something like that. Anyway, you don't need to know x. E is in your calculator. So the only thing you need to know is a. So it's only one parameter that has to be estimated. Hence why it's 1. So just to recap what I just said, in order to know what your m is, right? If you don't see anything mentioned about a normal distribution in the question, nothing about the binomial, and nothing about a Poisson distribution, then assume your m is 0. Otherwise, if you see a normal distribution in the question, then your m is 2. Okay. If you see the binomial or the Poisson, then your m is 1. All right, I hope that's clear. I'm going to go to the chat. Because it's a different test, Navineepo, that's why. It may be a chi-square distribution test, but the statistics behind it, in order to work with the degrees of freedom, is different. It's beyond the scope of this course. It's quite mathematically intensive and very theoretical, but I wouldn't be able to go into it now. But you're not tested in it. However, you just need to know that it is different. Sorry, that's the best answer I can actually give you for this level of the course. But it's worth reading up on it if you should like. If you're not sure, I can direct you to something that could guide you. Just remind me. All right, but the main thing is everyone understands how to get the m. Okay, it's very important. Okay, so m is 0, k is 3. So if you put that all into the equation, into this equation, all right, you're going to have 3 minus 0 minus 1, which is 2. That's your degrees of freedom. Okay, so I'm going to clear this table out. All right, so we got degrees of freedom, and then our alpha is given to us. Level of significance 5%. 5% to 0.05. So we go to our table in our textbook, and I've copied that actually to make things a bit easier. Paste it here. So remember, in our table, which will be given to you in your exam, here's your chi-square distribution. Okay, so we look at where alpha is 0.05, 5%. There's our alpha 0.05. So anywhere on this axis, on these columns, there's 5%. And our degrees of freedom is 2. So where they intersect, there's 2 in your degrees of freedom. So your critical value is 5.991. 5.991. So that's our critical value. So if I had to draw it, I'm going to draw the rejection region. Like that. Remember, our chi-square distribution is skewed. You remember last week's session? I hope you do. Just recapping. It's a skewed distribution. It's 5% as your alpha there. And this value, this critical value, is what we found in this table, which is 5.991. Okay, so I'm going to remove this table now because it served its purpose. Now that we have a critical value, we can state that anything on the right of this value, we will reject H0. And anything on the left of it, let me put a different color so we don't get confused. Anything on the left of it, we accept H0. All right, so that's step 1 and step 2. Okay, now let's move on to step 3. Step 3, just like last week, is where the bulk of the calculations take place. Right. So what we would need to do is we would actually have to create a table with those 3 categories. So if I'm gonna use black here now. So the 3 payment methods: cash, debit card, and credit card. Right. So I'm gonna write it here. So cash. I'm just gonna write C for cash. Debit card is DC, and credit card is CC. Okay. Just know I'm just writing short form. Okay. So in our first column is what's given to us in this table, and that's our F0, the observed frequency. So we got 41 for cash, we got 49 for debit card, and we got 110 for credit card, and that's our F0. Now, for the chi-squared statistic, if you remember the formula I showed you last week, we actually have to work out this formula here. F0 minus FE all squared over FE. All right, so this was covered last week. This is what we ultimately need to work out. And we need to create this table in order to work this out. So if you look at this formula, we've already got F0. There's our F0 column. The thing we don't have is FE. Right? So we're going to create another column here, and we're going to work out our FE. Okay. Now FE, this represents the expected frequency. Now if you look at this table here, what I've completed, we have FE as a percent. Right? But we want to know what the actual numbers are, not the percent. What are the numbers of customers that we expect to pay by each payment method? So let me ask you this, right? If you had 200 customers in total, and you expect 23% of them to pay by cash, then what number do you expect to pay by cash? I'll say that one more time. You have 200 customers in total, and you expect 23% of them to pay by cash. So what number do you expect to pay by cash? Can you write that in the chat? What do you think it is? Excellent. Very good. That's right. Now how you got that is you took 23%, and you multiplied it by 200, and that's how you got 46. Very good. And you do the same thing for debit card. Okay, you know the expected frequency, which is 35%. So 35% times 200 will give you 70. Right? And then lastly, if you do the same thing with credit card, you would get 84. And if you wanted a sense check, you can add them up and you should get back to 200. All right, so 46, 70, 84. Very good. Okay, so I'm glad everyone's following that. But I'm just going to go back to the chat and see if anyone didn't follow what I just said. Assume all good. Please let me know otherwise, all right? It's very important you understand how to get FE, because if you're stuck there, you're not going to get the final answer, and then you're going to lose all that marks. All right, so let's go back to the board. All right, so we got our FE. All right, so you got F0 and FE, and it's pretty much what you're trying to do is you're just going to compute this formula that I have here. You're trying to compute this formula. So you could do it in one step and just do it in the next column. It's up to you, but I'm going to break it down into steps. All right. So I'm going to get the numerator first. This here, you're going to have the numerator first, so it's going to be F0 minus FE all squared. If you do that, that's basically just subtracting these two, 41 minus 46, right? And then you square it, you get 25. And so how you get this 25, I'll just write it here. It's 41, it's your F0, minus 46, and you square that difference. You do that, you get 25. Do the same thing for the next row, 49 minus 70 squared, you get 441. And then lastly, you get 676. All right, okay, it would be, okay, almost there. Got one more column to work out, and then we're done. Okay, so the last column, if you look at it, we've got this numerator. All we need to do now is divide by FE, the new denominator. So we take this, everything that we have in this column, and we divide it by this column, right? So that'll give us our F0 minus FE all squared divided by F. All right, if you do that, it's going to be 0.543. Next one is 6.3. And then lastly, it's 8.048. And then we're done. You've done all the hard work to get the columns. The last thing you need to do is remember this is a summation sign. So it means sum this entire column. Add up this entire column. If you do that, that's your chi-squared statistic. And if you add them up, you add all of it up, get 14.89. That's your test statistic. Now looking at 14.89, does it fall in the rejection region or the acceptance region? So what I'm asking you is, do you accept H0 or do you reject H0? Can you write that in the chat? Based on what we found in step 3, yeah, do we accept or reject H0? Excellent. Nicely done. Well done. All right. So you can see that 14.8 is much bigger than 5.99. So it's going to be on the right of it. It means it's sitting in the rejection region. So that means we reject H0. We reject H0. And we accept H1. Okay. So what does that mean in terms of the payment methods? Are they the same or are they different? That's the last question I'll ask you for this evening. Based on what we found now, are the payment methods the same or are they different? Yes, yeah, that's it. It's different because we reject H1, so it means H1 is correct. And H1 says that the payment methods are different. And so to conclude, write a statement to conclude. Okay, so I'll write it out so you have an idea of what we look for in the exam. Okay, so I'm just going to make some space here. I'll type it up. In conclusion, we always start with the level of significance. In our case, it's 5%. So at a 5% level of significance, okay, oops. Okay, we reject H0. Therefore, we conclude that the payment methods have changed. That's it. Question is answered. And that is the goodness of it test. All right, any questions? That's your conclusion. Hey everyone, that is the end of quantitative techniques. I hope you enjoyed the content and you've learned something that some of you might apply in the real world. Hopefully you do. But if anyone does talk about statistics at work, you kind of have an idea what they're talking about. What you covered in this course kind of covers I would say the most commonly used stats tests, regression, the probabilities. That's what pretty much is used in the industry. So at a high level, you have a very good understanding of what it's all about. And I hope, a lot of it made sense to you. Yeah. Any questions? The floor is yours now. Or is everyone all good? You're welcome. I'm very happy to hear that. Go back to the whiteboard. Yes. No, I'm still copying it. Oh, okay, sure. Not a problem. Okay, but I hope you understood the content. It's okay if you just copy the notes. That's fine. If you want, I can actually try and paste it in the chat. And yeah, I hope the live session helped. And the content was clearly explained, and you enjoyed the course. So, can someone maybe put in the chat, what is the date for your exam? I need to check the pairs and just plan accordingly. I will do a session on revision. Can someone just put it in the chat? I think we might not have a session next week. I don't think we'll have a session next week. Maybe the week after, because it also gives you some time to do some revision, and then I need you to tell me what you'd like me to cover. And obviously, I can't go over learning Unit 1 all the way to 9 again. But if there's one that you are finding trouble with, please drop me an email, let me know. That's the one I will focus on. 26 June. Okay, so we got some time. All right, so there's definitely not a session next week. Next week, say, is the 21st. 21st. Yeah, so no session next week. If I don't get any questions, say like within next week, then we won't have a session in the following week. So I will message the group when we are going to have the session. Right, so I'm going to give you some time to go through past papers, go through the tests that are made available for you on the platform, and then I'll have a revision session after that. Okay, but I need the feedback from you to tell me what you're struggling with. Okay, so and the only way you'll know that is when you start revising. The past papers. Vinikachi, I think your librarian can help you with that. Yeah. Contact your online librarian, and they would be able to do that. Just remember, this course has changed a bit in the last year, because before it split into 2 courses, and now you also have questions where you can choose from, as you saw in your assignments. You don't have to answer 3 and 4. You get the choice of answering them. So that's also changed. But if you get a paper from last year, it should be the same as what you expect to be asked this year. But before that, the course was different. Okay, so just keep that in mind. There's also some content that was in the previous course 2 years ago that is not being covered now, like confidence intervals. You're not being tested on that now, but it was in the course then. So just a heads up on that, okay? Okay, does that answer your question? So contact your librarian. They should be able to assist you with that. Any other questions? Sanganipo, you managed to copy the final statement? Let's go back to the whiteboard. We all good? No problem. All right, everyone. That's it for this evening. I will make the recording available tomorrow. And thanks for joining. Chat soon. And yeah, feel free to email me with any questions that you have, okay? All right. All the best, everyone. Just Travis, sorry, you asked a question. Task 2, do you mean assignment?
Yes, so sorry, I mean assignment 2.
So from my side, the marks have been sent to the results center, but it's left to them when to release it. Yeah, so they'll notify you.
Okay, yeah, because I'm having issues with seeing all my other results as well. So same with financial management. They said that they've been released, but nothing's showing on Arc or the portal.
Is it just you though?
Yeah, so it's just me from my financial management class, and then my accounting marks aren't showing either.
Oh, okay. That's something you have to log with DC Assistant.
Yeah,
Yeah,
because
it's not like a general thing. Yeah.
I sent them a ticket, and they responded this morning saying the issue's been resolved, but nothing's changed.
Oh, yeah, I'm sorry. That must be
Mm.
frustrating.
Okay, it's all good. So,
All right.
yeah, cheers. Thank you.
Yeah, no worries.